I guess we won't have protests if we start 3 minutes early. Okay, let's start.
It's a pretty easy agenda.
Yes, well, yes.
So
Can I have a motion to approve the agenda?
moved.
All in favor? Aye. All right, let's start with the first one. The authorization of a contingency increase. This is not necessarily one of them, but anyway, go ahead.
So it could be. So far, we haven't heard much from contractors, and we have been probing, but it's likely. Definitely something to keep in mind. So, as Mr. Sultan said, I am here to request authorization for the increase in the contingency for the construction contract for Lansdowne sewage pump station reliability upgrades. Just a quick refresher on the project as well as its status. The purpose of this project was to perform comprehensive overhaul of the facility to increase its reliability and regulatory compliance, and basically ultimately, avoid incidents such as SSOs and other failures there. It's a 20-year-old facility, little over 20. It was, I believe, commissioned in 2004, developer built, and maybe, for that reason, some of the standards back then, sort of resulted in some changes that we've now had to sort of work through as we initiate construction. The board approved the contract for this construction project back in June of 2023. It was awarded in July, NTP shortly thereafter. And so we're obviously over a year into construction, and the original contingency that was authorized was $160,000 for this project. So as I said, we've seen some changes along the way. Some of these changes can be categorized between miscellaneous design changes and owner requested improvements. But these two categories cumulatively account for about 20% of the overall total changes that we've seen. Unforeseen subsurface conditions not only account for the remaining 80%, but single-handedly by themselves exceed the original contingency that was approved by the board back in 2023. Owner requested is us. For instance, hey, the grinder motor is exterior located, neighborhoods nearby. We'd be more comfortable if we included an enclosure for sound attenuation. We vet the idea, we consider it good, and we incorporate it. That's sort of an example of an actual change that was incorporated into this project for that category. So the picture here sort of illustrates the point of what we saw when we started undertaking some of the work, and we'll get into a little bit more detail on it. But basically, this electrical conduit that you see here was indicated for reuse for the current project. And when we got in there to perform some of the work, we noticed that it was not only not very deeply installed. In some areas, it has less than a foot of ground cover. It was in direct contact with some steel pipe that was on the ground, which for electrical conduit is a little bit of a safety hazard. Not encased, insufficient capacity. We saw a lot of issues with that. Some of the existing pipe that was there was installed under concrete pads, which we typically don't like. Obviously, in case we need to get back in there for leak repairs or whatever, it sort of becomes a hindrance. Lots of subsurface conditions issues. And so to deal with this, in the case of the electrical conduit, we decided that not only for dealing with the issue of safety, capacity, and lack of adequate protection for it, The best solution would be to route from the interior panels and devices out along the retaining wall that's pictured in the back here, hit these new junction boxes and go underground at the proper depth with the proper bedding, proper routing, and hit the devices outside. And so we went 17 new conduits between 1 and 2 inch diameter, rigid galvanized into PVC buried. Like I said, new junction boxes, new wiring, testing, and it sort of also just increases the general condition and reliability of the pump station along the way. So, as I said before, that resulted in a pretty hefty amount there, exceeded our original contingency. Smaller amounts that by the time we ran into this stuff, we had probably spent something like, 40 to 50,000 on the other changes. And so the overall contingency deficit ended up around 50,000. So we are here to request $100,000 to cover not just that deficit, but any future, unforeseens that we might bump into during startup and commissioning. We still have a bypass system that's active out there, and things are looking good in regards to taking that offline when we complete the facility. But there's a risk there that we want to sort of save a little bit of a crisis fund for as well. This would represent an increase from the originally approved 5% to 8% of the overall construction contract that was originally approved. And so, still not quite tipping the scales into, uncharted territory in terms of what the ask is, but I'll place it before the committee here for approval.
One of the things we talked about on the phone was that the next time that you guys have a project with no as-bills, ask for an increased contingency right up front so you don't have to come back, because you're heading for trouble. So we may want to consider that the next time. But
Yep.
if you,
And we had talked internally a bit, and I believe this was part of Savita's conversation with Mr. Sultan, is trying we want to come forward even perhaps as an informational item to you in a future meeting to kind of lay out the criteria that we would propose for when we ask for 10% versus 5%, one of which
Yeah.
being R&R type projects with sort of as-built issues and so forth, where we just know we're kind of opening up an old facility. The other one that you'll recall came forward recently was this is a category of lower dollar amount contracts where the 5% multiplier really doesn't provide for much, and just, it was, I think, the East Maple
Correct.
project that you saw recently. So we want to develop a bit of a criteria that we will apply when we ask for the 10% over the 5%. And obviously we'll continue, Rick and Sam will be presenting on their quarterly report and our performance in managing the contingencies going forward. So.
Oh, yes, thank you very much. Put my microphone. This isn't the first time we've had an issue with an as-built, and some of the pump stations that were built by developers were totally abandoned and new ones put in, like the one on Ryan Road. And those went very cleanly, very nicely. I drive by it now and again. So that's good. I don't see any issues with it, but the only question I have is 8% going to be enough
On this project,
on this project? Yes, sir.
we believe we're far along into construction. We're just about to start initial startup and commissioning steps in March.
In March, okay.
So we considered the risk profile towards the end of the project when we set the contingency amount. I'll admit, at one point it was a little bit larger when we were kicking around the item back in December. But now, having seen what we've seen, we feel more comfortable with this being sufficient.
Yeah. Oh, and I just want to revisit, so so I'm clear. So for certain projects, you'd have certain criteria to determine what contingency would be, the 5% or 10%, based on what categorization the project fall into?
That's what we would
Yeah, no,
propose.
that's,
So
yeah, that definitely. I
we want to
definitely follow
create
that
the
logic.
confidence with the committee that,
Yeah.
you know, we're not asking for 10%
Yeah,
willy
because to have a blanket one is sometimes very difficult versus there are different types of projects, and that does make sense from a
Yeah, I think
approach.
another category that Elton didn't mention and Mr. Sultan mentioned at the beginning is these potential tariffs and how they're going to impact, especially on the steel and aluminum in our pipeline projects. And, you know, we have a lot of metals in our projects. So that might be another type of category where
Mhm.
we're looking
Okay,
at
yeah.
being able to kind of mitigate that risk.
Makes sense.
Mr. Chair, I have a comment. Is there any way to integrate earlier level SUE, higher level SUE studies or ground penetrating radar when we don't have as-built to kind of foresee this at design?
There could be, and I thought about that when we were looking at this item. One of the things we sometimes do in facilities, especially when we are destined to install new underground infrastructure, is to perhaps test pit some of the routing to ensure the accuracy of the as-built, especially if there's a little bit of a question on its age or who developed it or whatever it is. On this one, to reiterate, we didn't anticipate the need to install anything subsurface. So I think even if it had been considered, and I wasn't involved in the design, but if it had been, perhaps it would have been determined that maybe we don't need it. Obviously, some lessons learned from this project to carry forward. But yes, sometimes we do sort of those early investigations to rule out some potential surprises along the way during construction.
Something along the lines of what you're describing that we've done in the past is for some of our pipeline projects where at 30% we've done SUE and test pitting and obtained information. By the time we reach 90%, enough time has passed, enough fibers going into the ground everywhere that we do another round of SUE, then that doesn't address project like this.
And my question is just, does it make sense when there are no as-built to kind of elevate the level of
Yeah.
SUE effort, even for small?
I think it
I
does.
believe so.
But I think in this case too, still would have had the safety issue, which we wouldn't have been able to pick up with SUE, right? So with the conduit sitting on the pipe, it probably wouldn't have picked it up. But yeah, it does.
Until you put the backhoe, uncovered it. You didn't know.
Right.
I
I
have no
have
other
one
comment.
I have one general question. On owner requested items, what's the process or where does that go?
I can
Who has
feel.
the final, oh,
I
Who
can
has the
field that
final say?
one. There is a lot of conversation with end users on our side when these types of asks come up. And it really is at the discretion of capital programs in collaboration with those end users to sort of figure out the cost benefit with the contingency in mind, right? There's a lot of nice to haves that unfortunately we don't feel are prudent to incorporate if they exceed a certain portion of the contingency that perhaps if it's early on in the project, you know, we're not really that comfortable with spending, you know, 25% of our contingency on a nice to have. We can promise to incorporate that in a subsequent project. We can look at other avenues for contracting for that work, but it's typically vetted in the context of the contingency that's available, how early on we are in the job, what the risk profile is for that project, and the criticality of the request itself.
who makes the final decision?
There's a fairly detailed documentation procedure. So the project team prepares a form and all of the justification, and that goes through a routing process that goes through the director
it
to myself, and
goes to you?
ultimately Brian signs
All the way up to Brian.
on the
Oh,
change.
okay.
But I guess not to add too much, even before it gets routed up, there's a lot of discussion, right? I guess by the time it does get routed up, there's formal authorization, but we talk amongst ourselves more than you would expect about all these changes and typically try to be mindful and responsible, even though we know, you know, we want to make end users happy. It's not always possible.
So by the time it gets to Brian being a numbers guy, it's pretty well vetted out.
I guess that's my point. Yes.
Okay.
Any other questions? I'll I'll make the motion.
Okay.
I move the recommendation to the board to authorize an additional $100,000 in contingency to be controlled by the general manager for the construction of the Lansdowne sewage pumping station reliability upgrades project. The revised total authorized budget for the project is $3,460,000. Additional costs will require board approval.
Want to put it on consent?
Yeah, put it on consent.
Second?
Have a vote. All in favor, say aye. Good. Next item,
Thank you.
approval of the study task order.
Picture of the conduit was, the before was telling. You drove it home.
Good morning, Mr. Chairman and the members of the committee. I am here this morning to seek your approval to award study task order to RK&K for Elk Lick and Upper Foley Pump Station force main corrosion assessment. So south of Route 50, there are two pump stations that are subject of this task order. Elk Lick Pump Station is in South Riding area and Upper Foley Pump Station is in Stone Ridge. So these two are pump stations that are subject of this task order today. Some more information about these two pump stations. Both were built by developers. Upper Foley was commissioned in 2004. Currently, we see on an average daily flow of 1.3 million gallons per day out of Upper Foley. Elk Lick was built in 1995 to serve South Riding area. And currently, we see average daily flow of about 1.5 million gallons per day. Combined between these two pump stations, there is approximately 9 miles of force main ranging in size from 16 to 20 inch. Upper Foley has one force main that goes to the gravity sewer. Elk Lick has two parallel pipes that goes from pump station to the discharge manhole at Route 50. And one thing I want to add, and that's the key thing for this study, is both that entire run of force main, these are ductile iron pipes, and at the time of construction, they were provided with galvanic anode-based corrosion protection system. Little bit of background and drivers for this project. The exhibits that you see here is if we were to do this force main today, these are Loudon Water's standard construction details. That's how we require the anodes and test stations be placed. So every year our asset management team they go out to the field, do as part of routine condition assessment of our asset. They take the reading on these test stations to better understand the condition of the corrosion protection system, right? Last couple readings, I think the latest we did was last year. These readings now indicate levels that suggest the anodes have started to either deteriorate, deplete. So basically suggesting that the corrosion protection system has come to end of life. So anodes are like they're the foundation of corrosion protection system. They sacrifice themselves to protect the pipe. And now since they are deteriorating, in absence of a functioning corrosion protection system, the pipe will start to corrode, right? So, and both these pumps, the population that they serve, they're quite critical, and the consequences of failure of these force mains, the consequences of failure is very high. So this resulted in a need to move forward with a study that evaluates to better understand why the issue, and then the mitigation measure. What's the optimal repair and rehab strategy to address this issue? So that's the goal of this task order. So at a high level, with this task order, what we're trying to do is the consultant, a lot of field work involved in this task order. The consultant will, they will look at the test readings that we've taken last couple of years, the as-built, whatever info document is available, existing record documents associated with these force mains. And in addition, they'll go out to the field, they'll carry out a corrosion protection survey. They will do soil resistivity testing. This is surface testing, but they will do it throughout that 9 mile length. They will they will perform electrical continuity testing to make sure any recommended or measure that we implement does work, because you want that electrical continuity between the pipes. So that's something they'll verify with this task order. And after this preliminary field work is completed, we will also expose, now this is difficult, expensive, so we have to be selective on how many locations we do it, but we will identify 6 to 8 locations where we will expose the force main and visually inspect the pipe, and then also do ultrasonic testing to better understand if the deterioration has already started in the pipe or what's the condition of the pipe, right? So now that one would, how many locations we do will depend on some of these preliminary findings. And after all these field findings, the consultant will develop alternatives to mitigate the issue. Everything will be packaged in a technical memorandum along with cost estimate, construction schedule, and things like that.
And one question, what do you find from the ultrasonic testing?
The thickness of the pipe,
What?
thickness of the pipe. Yeah, so if the pipe has already started to corrode, you can see like whatever the initial thickness was, it'll start to give up, right? If it's corroded, and that's what they use that ultrasonic testing for.
And you do that from the surface or after?
No,
exposure?
so after we go through this first series of field studies, the consultant will be better informed to select like what locations you want to do these visual inspections and ultrasonic testing.
Just outside diameter measurements.
Yes, that's my understanding. So this slide here is a little bit more granular detail of what's included in this task order. Project management are typical to all our task orders. This involves meetings, invoicing, project updates. The first set of work will be preliminary corrosion analysis. So that's more a desktop study of existing information, and some surface studies like soil survey, corrosion protection survey, electrical continuity testing. And based on the information from this preliminary, the consultant then will move to more investigation that will require excavation, right? So that's where the visual inspection, ultrasonic survey will be done. And since we will have some excavation, the consultant will also take some grab samples for soil corrosivity, so lab analysis for the soil corrosion potential. So that, and better informed with these investigations, the consultant will then move into the next phase. That will be to evaluate alternatives that are available to address this issue, associated cost. And like I said, everything will be packaged in a technical memorandum for Loudon with their recommendation. And Loudon Water will make a decision on how to proceed based on the recommendations, based on the evaluation alternatives that they provide. Take a pause here if anybody have any question.
Is there a certain number of alternatives that they're obligated to come up with in terms of?
Yeah, no. So when we were scoping this, we looked at like what could be the outcome, right? So one obviously is do nothing. The other would be like replace everything. So in between those two is there could be what they refer to as hotspot fix. So with this study, they want to see if there is any pocket of these force main that have like higher deterioration that you can kind of go and address quick, right? So the other would be just to replace the anodes that are existing. So when they originally did it, they installed 20-pound anode bags. So maybe we go and just replace what was originally installed. The other potential option is impressed current. Now we basically switch from galvanic anode-based corrosion system to impressed current, right? Which is considered like a higher level, but because this is a retrofit project, may be cost effective. So that's something our consultants will look at as part of this study.
Okay. And a lot of in terms of it will be based on the ultrasonic testing that help define if you're going a path of maybe, trying to fix certain selected spots. Is that primarily based off the ultrasonic testing, or is there other things, other factors that will?
So the hope at this time is ultrasonic testing will reveal that the pipes haven't deteriorated, right? So the corrosion protection was functional. It still is functional. It's just like so if the pipes are in good condition, ultrasonic testing is just one more data point that would tell us like what is the what is the actual condition of the pipe.
Okay.
I mean, if it hypothetically, if it turns out like the pipes have already corroded, yeah, I mean, we may have to go to a more higher level of fix than what we think is needed for this force main.
The anodes, do you have to, how many lengths of pipe would one anode of generally?
So in Elk Lake, in that 16 in a mile run, 4 miles in Elk Lake, there's only like 4 anode beds. So they're like in 4 segments, right? And each segment, I believe, is about 700, 500, 600 feet. And then you have a gap, and then you have another set of bed. So that's how it was installed in Elk Lake. So that's one of the things we have to look at. And to make things a little complicated, Elk Lake Force Main runs through the golf course. So it may not be easy to go back and replace anodes where they are. So that's part of the study, is we have to see which location is feasible to put the anodes back. So these are all, again, there are some complications here that needs to be looked at during the task.
So you don't have to bond adjacent pipe to keep electrical continuity through more than one pipe?
So that.
Or do you have to bond
and-
across a joint?
So that's part of this study, is they will make sure that the bonding hasn't deteriorated. It's still
There is
functional.
bonding
Right?
across a joint?
Yes, it is. It was bonded originally, and they will test to make sure that bonding, electrical continuity is still there. That's part of this task order. Yeah, I mean, if they start finding like the bonds have, there is no bond, then it just adds to what you need to do to fix this issue. So we selected RK&K for this task order. RK&K is one of our BOA civil consultant. They have provided similar service to some other municipal utilities, as well as larger private utilities like Duke Energy, Dominion Power, and some gas transmission companies. And here you have is a summary of breakdown of fee. And I just want to point out that this is, for the purpose of this presentation, the actual spreadsheet, the fees were developed from bottom up. It's a much higher granular breakdown than what we're seeing here, the way we came up with the fee. And I also want to point out, like a big chunk of this fee, $112,000, is an allowance for excavation and restoration. So the reason we could not we do not have a sub-consultant at this time is where exactly do you do that location is to be determined after some of this early work is completed. So there was some uncertainty on how many we will need, how deep you need to go. So what we thought the best path forward is set aside allowance, and once we have a clear picture of what needs to be done, we'll go out and get quote from a couple contractors and then get their service to expose the pipe for consultants to go down and do the testing.
Is there any thought of doing that in-house?
We talked about it. There is, again, a little bit of a resourcing issue, and also we're limited to how deep we can go. We prefer to, or we can go with the equipment we have. Some of this force main is like 10, even like 8 to 10 feet deep, and we just do in-house. We do not do that. And
So, you'd have to use a shoring tool.
yes, so
Yeah.
just, yeah, you have, so it primarily because we do not exactly know where we need to do this location. So that would be something we will look at again when we pinpoint the locations that we want to do the testing.
So that particular cost for excavation and restoration could go up.
It could, yeah, and for 2 reasons, right? One is if depending on where we select and how deep those locations are, and also once we do a couple, if there is something concerning that we find, we may need to add. Right now, we're estimating 6 to 8 locations that we need to do ultrasonic testing. But if those suggest like we need to do more, it will add to the cost.
Would you think, because this is a developer built, as built, that it would be a candidate for a higher contingency, since you also have, an estimate built into it?
So this for now, I mean, if we were talking construction, definitely yes. But this is just study, and I think the scope is pretty thorough. I do not expect needing additional contingencies just for the study, other than with the caveat that excavation is subject to like what we find with this early.
I respect that you want to stay in budget, so good. I'm happy to hear it.
So I think this, no, this is not my last slide. So this immediate task order, we're requesting approval today. We expect this to be completed in about 6 months. And depending on the option that we decide to move forward, the next phase will be detailed design. Most likely we'll bring back to the committee, like say in 6 to 8 months. This project is, we're tracking this in our 10-year CIP plan under West 88. And the allocated budget for the project is $2.63 million. And Mr. Chairman, this is my last slide before the motion. So if you have any questions. All right, with that,
Thank you.
I have the motion in front of you.
I'll do it again.
Okay.
I'll read them out. I move the recommendation to the board to award a study task order for the Elk Lick and Upper Foley Pump Station Force Main Corrosion Assessment to RK&K LLP for $283,800 with an approximate 5% contingency to be controlled by the general manager for a total authorized budget of $298,000. Additional costs will require board approval and put this on the consent agenda.
Second.
Call for a vote, all in favor?
Aye.
Thank you, sir. The next one is approval of design task order.
To this presentation that we've got today. So we've been in front of you a lot, talking about the Broad Run Phase 3 expansion. That is a large capital program, but we're going to have continual small projects that still need to occur in the plant that when you start lumping R&R and small improvements in those larger expansions, they take longer, they're harder to get done. We don't want continual change orders on those type projects. So we'll still have these small projects that come forward and need. So Jen Caberline is our plant manager at Broad Run, and she's going to, present on this project here today, but you will continue to see R&R type work coming in on electrical rehab, concrete rehab, and we're evaluating when this makes sense as standalone, and we'll continue to bring forward those packages for you.
I just want to add that you guys are doing a fantastic job.
Thank you.
To get done what you got done without interrupting the plant, at least that we've heard of. I think you're doing a great job on that.
Yes, I would say one of the big accomplishments of that job was the construction did not cause any permit violations, which is what all of us on the operations team kind of worry about as we go to sleep at night. I also just wanted to add that we do acknowledge there are complications with multiple contractors operating on the site, and we do evaluate that as we bring these forward to you. But I think as you bring up the expansion that we just completed was a great example where we did have a separate project on site with the reclaimed water pump station, and the team was able to manage those two contractors very well. So we've got a lot of experience in really managing this on site, and I think can continue with this approach.
Good. Thank you, Kendra. Well, good morning. As Kendra mentioned, I'm Jen Caberline. I'm the plant manager at Broad Run, and I'm here this morning to seek approval of a design task order for improvements to the flow equalization and the solids handling processes at Broad Run. So just briefly on the agenda today, first I'm going to talk through some drivers and the scope of work for the project. Let me see if I get this working. Okay. So the two process areas at Broad Run that are included in this project are flow equalization and solids handling. Those are highlighted in blue here. These processes are relatively independent of each other. They're very different processes at Broad Run. However, the needs for improvements in these areas are on a very similar timeline. So we've grouped these two, the improvements at these two process areas into the same project. So I'm going to talk about them individually. I'll then walk through the overall design fee, the schedule, and provide a recommended motion. Okay, so first I'm going to talk through why we need flow improvements to the flow EQ process or equalization process at Broad Run. And really what it comes down to is that the flow EQ process at Broad Run is a critical component to our overall strategy for managing and controlling flows to the Potomac Interceptor. And we need to be able to control how much flow we send to the Potomac Interceptor because we have these contractual limits of 13.8 MGD 12-month rolling average and the 31.9 MGD peak hour flow. Within the past year, we've actually started to see that peak hour flow to the PI approach and reach that 31.9 peak hour limit. I think we're all aware that in the future, wastewater flows are just going to continue to increase. So, we anticipate that in the future, we're going to see more frequent and higher peak flow events, and we need to be prepared to handle those peak flow events. And so, one of the things that we really need to do in order to be able to, better control those flows is to make improvements to the flow EQ system at Broad Run and to allow that process to be a bit more automated. So I'm going to take a step back and talk through how the flow EQ process at Broad Run is physically tied into this Potomac Interceptor flow control. So looking at the map here, in the tangent area, all of the wastewater that is generated from the sewer shed is conveyed to and treated at Broad Run. All of the flow up here in the blue shaded area that's generated here, that is all sent to the Potomac Interceptor and is treated at Blue Plains. Within the purple shaded area here in the Russell Branch sewer shed, I have a hard time saying that all in one sentence. In the Russell Branch shed, we have the option to either send all of the flow that's generated there to DC water for treatment or to send a portion of that wastewater to DC water and then a portion of that to Broad Run. Now, we try to send as much flow as we can to Blue Plains with also staying within our contractual limits because it's more economical for us to treat wastewater at Blue Plains as opposed to Broad Run. But in order to maintain our contractual limits, we do have to send a portion of the flow that's generated from the Russell Branch shed into Broad Run. So I'm going to walk through how we accomplish that on a more granular level. So looking at Broad Run, we have our 3 EQ tanks here. The Russell Branch Interceptor, this conveys flow from the Russell Branch sewer shed to the Potomac Interceptor and to DC water located up here. We have an existing diversion structure that's located on the Broad Run property that what we do is we can open a gate in that diversion structure to allow flow from the Russell Branch Interceptor. Hit the wrong button there. From the Russell Branch Interceptor into Broad Run. So this is how we get flow from the Russell Branch sewer shed into Broad Run. Now, the Broad Run process, the biological process at Broad Run really thrives on a continuous and steady incoming flow. I think we're all aware that flow does not come into Broad Run in a steady manner. It follows a diurnal pattern. So there's times during the day when flows are higher, times during the day when flows are lower. And so, for example, if we want to send 10 million gallons per day through our secondary treatment process and flow is coming in at 16 MGD, we attenuate that 6 MGD of flow in the EQ tanks. And then we're able to store it in the EQ tanks until flows drop down. And then we can send the flow that is stored in the EQ tanks back through the Broad Run process during times of low incoming flow. Now, we also have the ability to send flow directly from the EQ tanks back to the Russell Branch Interceptor and then back, that goes to the Potomac Interceptor and to DC. So you can see that these flow equalization tanks and the flow equalization process is really very critical for our ability to control how much flow we're treating at Broad Run, but then more importantly, in the context of this discussion, how much flow we are sending to the Potomac Interceptor. So similar to how we attenuate flow in the EQ tanks to regulate flow to Broad Run, we use those EQ tanks to shave peak flows to the Potomac Interceptor. So it's really critical that we have a robust process here. And The goal of this project is really to automate that peak shaving process. So right now we control flows manually. So we look at how much flow is going to the Potomac interceptor. We open that gate at the diversion structure, a certain percentage to send flow into Broad Run. But in order to automate that process, we really need some new flow metering. So we need a flow metering vault on the large 48-inch line, so existing 48-inch line that comes into the plant from Russell Branch. And we also need a new metering vault that goes out from Broad Run back into Russell Branch. So the flow metering, again, large diameter sewer, 48-inch diameter sewer, and then a 12-inch diameter sewer. So new metering vault there. And then we also need to make some improvements to the valves that are in the EQ vault. So each EQ tank has a respective EQ vault. So we do need to make some improvements to the valves that feed those tanks to make them a bit more robust to allow for actual flow control. Right now they open and close. We need the ability to throttle those valves. We need some more yard piping as well to help with the flow control in and out of those EQ tanks. And along with all of this, obviously, if we're going to automate the process, we need some programming, right? So we need to incorporate programming into these improvements to allow it to be a bit more automated. So really, again, what it comes down to is that all of these improvements collectively to the EQ system will help us to better control and automate the amount of flow that we're sending to the Potomac interceptor in order to maintain and stay within those contractual limits.
I
Yeah.
have a
So
silly,
today,
I'm sorry. go ahead.
so today, you, if you want to change the flow, you have to call somebody on your team and they have to go to the wheel and change it to a certain point.
Well, yeah, we're able to remotely through our SCADA system
Oh, it's the-
change.
oh,
Yeah,
oh, there
yeah,
is-
we're able to
I just saw
open
the
the.
wheel. I was thinking that, I thought that's what you're saying.
Yeah.
So it's already hooked up to the
It's hooked
SCADA
up to
system.
SCADA, but right now we have to manually decide how much we want to open that gate and how much
So
we want to
with
send
flow
flow.
meters, you would be able to automate that.
Exactly.
Done.
I would say it's also right now a delayed process, but without those meters, so we have to wait to see
Mhm.
what the flows were to figure out if we opened it enough or not, right? So it's why the metering is kind of key to seeing it live as we're doing it.
Yeah, absolutely.
I mean, we keep talking about DC, the interceptor. Contractually, what if we exceed the number? What's the penalty?
Yeah, so our contract is extremely detailed on what happens on that rolling annual average, that 13.8. And that is a slower, longer process. So we've been able to manage that contractual limit just fine. The contract is not specific on what happens when you exceed the 31.9. And as flows throughout all of Northern Virginia have increased, that's more of the partners on the IMA are starting to see they're reaching those peak flows. So DC Water right now is really trying to figure out what to do with this issue. So there isn't a strict penalty if we exceed that peak flow once. But this action is really Loudon Water being a good partner. We, I would say ahead of most of the other IMA members have been ahead of staying within the 13.8. That was the point of the entire BRIPI project, was we knew we were going to exceed it. And so we've seen the peak flow reach it. We're staying ahead so we can control it while DC Water kind of figures out what they're going to do with all the peak flow issues. So 2 years ago, they started with an updated modeling project on the Potomac Interceptor to understand where peak flow bottlenecks are and what solutions might be. So they seem to be approaching it from the point of view of how do we just fix the peak flows rather than punishing for the peak flows, but that is yet to be determined.
So there's no, it's just being cooperative. There's
Yeah,
no-
right now.
Okay. Do we expect to be able to quantify the benefit of automating the process here?
I would say the benefit is in negotiation, if that makes sense. If we can control that peak, because that's where the Potomac Interceptor is limited, it gives us the ability to negotiate, well, can we increase that rolling average when there might be room in that pipe and not the peak? So none of that is negotiated, but those tools are incredibly valuable when we look at future construction. And is the timing going to be there? You know, the more ability we have and can demonstrate to them now, look at us control those peaks and bring flows in when we need. It helps us in those future negotiations when we might need more long-term annual average capacity on a little basis. It also helps us to be a good neighbor with our partners like Fairfax County, because we are switching flows back and forth in our area of the PI. So the more we have this ability, the more it helps kind of all of Northern Virginia. But it's kind of the Loudon Water way, right? To be progressive in this and show what can be done.
Yeah, it just seemed that at some point, it looks like there would be some cost benefit of being able to, with the automation and understanding the flows, when they should go to Blue Plains and save money to Loudon Water at some
Yes.
point. Yeah.
And I would say another benefit of this that is cost is right now, without that meter back to the Potomac Interceptor, we can't just automatically drain that big EQ tank back to the PI. So right now we treat that big EQ at Broad Run. So that's an easy one. And any flow we can get treated there, we know that cost difference and can show that on a easier basis. So absolutely.
Any other question?
No, this is very good.
All right, thank you. Okay, so moving on, going to switch gears and talk through the improvements to the solids processing, the solids handling process at Broad Run. And so right now at Broad Run, we have a total of 4 anaerobic digesters, and those serve to stabilize the solids that are produced as part of the biological treatment process. And those produce the product that is for beneficial use. We can land apply that product. You know, I know that you're aware, as part of the upcoming phase 3 expansion, we're planning to implement a thermal dryer downstream of the digestion process. And that thermal dryer will help to increase the overall capacity of our solids handling processes at Broad Run. Up until the point that we implement that thermal dryer, we really anticipate that we're going to be running up against the full capacity of that digestion process. So we're really going to need to be able to use the full volume of those digesters right up until, you know, the point that we implement that thermal dryer. The issue that we're running into is that the digesters create foam. And this has really been an issue that's come up over the past few years. However, it is very typical for the anaerobic digestion process. So anaerobic digestion creates a gas. The media is all mixed together. So between the mixing and the gas production, it produces a lot of foam. And so right now we're able to manage that because we're able to run all 4 digesters just at a lower level to, you know, account for some of that foam. But right now, out of the total volume that's being occupied by the digesters, 10% of that is foam. So in the future, in the next couple of years, we're really going to need to use that full capacity of the digester that, again, is really occupied by foam. And so we've identified, and we have tried, you know, multiple ways to help mitigate that foam through operational changes. But at this point, we really need to implement a mechanical system to help with knocking down that foam. And we have identified the foam busters. So the foam busters, I know it's silly, I'm sure y'all giggled when you saw that on the slides. But the foam busters really, they work by recirculating flow from the bottom of the digester to the top of the digester. And they have these specially designed nozzles, I'm going to picture it up here, that basically spray the digester contents from the bottom, recirculated to the top, and spray on the top of the digester to help knock down that foam. And so the implementation of the foam buster includes a new pump, 1 new pump per digester, new piping to convey that from the bottom of the digester to the top, and then the installation of the nozzles in the digesters. These digesters, they're pretty big. They're about 65 feet tall. So, that pump has to be designed to convey flow from the bottom to the top. We have a lot of piping there. One thing that's not shown in these pictures is that the basement of the digesters where this pumping equipment and piping will be located is actually really congested. And so there's a lot of piping valves right now. We're confident that we'll be able to fit all of this infrastructure in, but it's just going to be a bit more complicated. But again, it's a relatively straightforward way for us to be able to knock down the foam that's currently in the digesters and regain some of that capacity that we are going to need within the next few years. Yes.
You would do this as a mechanical process instead of using anti-foaming agents?
Yes. This is a more economical process than using an anti-foaming agent. And we have tried some anti-foaming agents in the past and we have it on hand, but it is actually very difficult to get that anti-foaming agent into the digester. And so this is much easier than trying to use
a spray system like you're going to put in here anyway.
Yeah,
so,
absolutely. And
yeah.
then that saves, you have the capital cost, but then that saves on, the cost for the anti-foaming into the future.
Appreciate that. Thank you.
Yeah. So this is a summary of the design fee and the schedule for the project. And so we've selected Hazen and Sawyer as the design consultant for this project. They're obviously, very familiar with the plant and with these specific processes. And so a couple things that I want to mention on the detailed design, the flow EQ design, it's complicated, but it's relatively prescriptive. We know where we want to head with that portion of the project. So with the design fee, we're confident with moving right into 60% design. So progress through 60, 90, bid, and then, 100% and then bid. So we save a little bit on the design there by just going directly to 60%. That's reflected in the fee here. With the solids improvements, that's a little bit more complicated. So we do want to go through all the typical design submittals there. So that's again reflected in the fee there. Overall, the fee is $615,400. Sorry. The overall estimated construction cost for the project is about $8.2 million. So that design fee is roughly 7.5% of the estimated construction cost. In terms of the schedule, we plan to kick off design immediately. The design schedule is about 12 months, go into a bidding period, and then construction to get all of these improvements implemented in about the Q3 of 2027.
Do you have to take the digesters out of action while you're doing the construction?
We do, yes, which is part of
You
the
have to empty it.
Yes, we have to empty each digester to be able to get those foam busters in. Yeah, we'll do one at a time. Obviously. Yeah. We'll do one at a time. And that's one of the reasons that we want to do this sooner than later, right? Is because, with the need for additional capacity, we want to get it done sooner because then it'll be easier to take one digester offline. Okay. Just a snapshot on the CIP. So we are carrying this project in the 10-year CIP, have the budget of $8.8 million for design and construction, and have the recommended motion.
I was, one other question. While you have the digester out of action, is there any other stuff that you can do to the digesters while it's down?
That's a good question. We don't have anything necessarily identified right now that would be, if we needed to internally make some improvements to the digester, do some maintenance work, then we would do that at the same time that the digester is done. But, in terms of additional work that would be as part of this contract, we don't have anything identified now, but we would take the opportunity while that digester is down to make some, if we needed to make some mechanical fixes. Yes, absolutely. Yep. Yeah.
But we could flip that statement around and just say, we do normally take one digester down for various maintenance activities or if a pumping system has clogged. So it's part of normal operations. So it's not something that we're not experienced with and do semi-regularly.
Thank you.
Other questions? Somebody want to make a motion?
I'll go ahead and read it. I move the recommend, I move the recommendation to the board to approve award of the design task order for the Broad Run BRWRF Flow Equalization and Solids Improvements project to Hazen and Sawyer for an estimated cost of $615,400 with an approximate 5% contingency to be controlled by the general manager for a total authorized budget of $646,170. Additional costs will require board approval. I'd like this to go on, I move this goes on consent.
I second. All those in favor? All right. Thank you very much.
Thank you.
Yes, good morning. I'm Andrew Beatty, and I'm here to present the study task order for the wastewater collection system master plan. This will be the last task order from me with relation to the wastewater collection system master plan, although you will see throughout the year other master plan task orders related to our water system and our reclaimed system. So you'll recall I was before you, along with my colleague Darren Geldert, to talk about wastewater collection system master planning in October, and that was specific to the model development, the all pipes model we were looking to build. And so this task order is sort of the final step in the process where we'll use the model and complete our master planning work. So just to recap, at a high level, the master planning process, we do our data acquisition, our flow monitoring, our research of existing studies that have been done, and the model development, as I mentioned, is underway. The calibration work will be part of this task order, and then we'll assign the allocation of future flows based on the projections work that has been ongoing and nearing completion. And then finally, use all of that information and those tools to do the baseline and future conditions analysis of our system, ultimately resulting in CIP projects for us moving forward. And the big questions, that this helps us answer, or as I said, it allows us to evaluate our existing sewer system with respect to existing conditions, the flows we're seeing currently, as well as analyze and evaluate the future projected flows that we anticipate seeing based on development that will be coming into our service area. Using the model, we'll be able to identify the deficiencies or the areas that need improvements that could be current or that will be anticipated with the future increases in the flows. And then, as I said, we'll be able to develop the capital improvement, identify the projects that will go forth into the capital improvement program, develop the high-level cost information and need for timing for those improvements. And then this will all be documented in our master plan report and complemented by the tools we'll develop as part of this task order as well. So as I mentioned back in October as well, the last time we did the master plan for the wastewater system was back in 2016, and there has been a tremendous amount of change since then over the last nine years or so. We've seen our service area expanded to include the new transition policy area close to the Leesburg, as well as our need to provide service to the Leesburg JLMA. Also with the county's comprehensive plan update in 2019, we have the new policy area, the urban policy area around the Silver Line Metro. So this is a new denser area of development that we have to plan around and accommodate in our system. You're well aware of all the data center growth that's been ongoing. New sites are still being developed, larger developments coming, and more recently we're seeing a lot more redevelopment coming through our land development process. So that's a newer area of focus that we're paying attention to. And then finally, the technological advances that Loudoun Water has made, specifically with the AMI metering on our water system, and then just with new analysis and visualization tools, Power BI and GIS-based tracking tools that can be used to assist us and help us. So for this particular scope of work, the work will include gathering and reviewing again our existing data, and this will include some of our asset management data, CCTV of our condition assessments of our existing sewer, our previous master plan, as well as the sort of IMA agreement, our interjurisdictional agreements. We'll review all of that information. A large part of this work involves the calibration and the validation of the model, and you'll see that reflected in the cost component that I'll present shortly. But really, it's critical that we spend the time to try and get the model to reflect as accurately as we can, you know, so that the analysis that follows, you know, will benefit us and be sort of as realistic as we think it could be. Then another large component of the master plan work is the actual capacity evaluation of the system and the alternative analyses. As part of the capacity evaluation, we'll be looking at our level of service goals, such as, you know, do we want to analyze the system with the pipes all full, or do we allow surcharging in the pipes, surcharging into the manhole? So these are questions we'll ask ourselves and work through as an organization, just to confirm what level of conservancy we're comfortable with, and that'll dictate then the projects that will be potentially needed. And then
I have a question. You don't, how do you know if they're running the pipe full, half full? I mean, you don't have the option. It's going to be whatever it's going to be.
It's going to be, but as we use the model to analyze the system, if we set our limits as we would we'd rather not have surcharging, then that may dictate that we need a project to upsize an existing pipe to accommodate future flows, for example. Whereas if we allow surcharging at some limited level of surcharging within the manholes, then that may not require upsizing of that run of pipe, for example.
And you said redevelopment, is that creating chaos?
It's an area we're looking at closely, and this master plan and the model in particular will help us better sort of quantify if if we're concerned or not. The concern is really just redevelopment in the upper reaches of our sewer sheds, where our pipes are typically smaller, whereas if we have a data center which could use a large amount of water and develop a larger sewer flow, then that existing pipe may be undersized to accommodate that flow. But I mean, as part of our land development process, we have the data center applicants do their calculations and prove to us that that's not the case. But this will just be another tool in our pocket to analyze those, or to try and look ahead and see if there are areas of concern. If an area was to redevelopment, could we anticipate that there may be problems?
Mr. Chair, sorry. This is magnified in the urban planning area. I'm glad you had that as the second bullet. We have 450 apartments that are coming online here in the third quarter at Moorfield alone, with 429 more planned. The plan has not yet arrived at Loudon Water, but the land development application has been signed. So it's going to be a mix of not just evaluating what's already approved density in the urban planning area, but what the Board of Supervisors approved for even greater density at the urban planning area. That is going to create some downstream effects, no pun intended.
Saying the research needs to be done.
Yes, the model will allow us to sort of move up our analysis in the timeline, because typically we don't we need to wait for the board to approve, you know, upzoning of areas to know
Can
what.
you use estimates of, potentially proposed projects that you've heard about?
Yes,
yeah,
yeah, and
yeah,
we do that.
yeah,
We do
okay,
that
okay.
currently.
Don't wait for the county.
Yeah. Our alternatives analysis, and that could be a range of things, such as just replacing the existing sewers and upsizing them. It could involve parallel relief sewers. It could look at our pump stations, the emergency storage we have currently. So there's a number of alternatives we'll look at as part of trying to resolve any deficiencies we identify. Another part of the scope for this task order is we'll develop the capacity and CIP tracking tool. This will be a GIS-based tool that will allow us to, as development is being proposed, we can update the flows in that and almost see what the impact would be to our sewers, so we can identify deficiencies quicker than waiting for than having just a static master plan. And then, as I mentioned before, then this will all be documented in a master plan report, complemented by the digital tools that will be developed along with it. This is just a recap of the schedule you saw back in October. Like I said, back in October, we were presenting on the model development, but today, we're targeting the master plan kickoff in the second quarter of this year, which is why we're ahead before you today. And the goal in terms of the schedule will be to have this master plan completed within a year, sort of by Q2 of next year, to allow us to reap the benefits from that in our CIP programming for the 2026 year and beyond. The negotiated task order budget is before you. Like I said, the primary costs are really shown, reflected in the model calibration and validation, as well as the capacity evaluation and alternatives analyses. For this particular model, there's nearly 70 calibration points, so it's a lot of things to try and match up and align as we're doing that calibration. So that's why the costs are shown here. And these are not, as you know, not to exceed budget. So if we can do it more efficiently, we will. So this will be at the total task order budget of $459,800. Our project CIP snapshot, and this is project wastewater 81, and our 10-year CIP budget for the overall master plan was $800,000. And this is my last slide before the motion.
I just have one question. I don't know if I know who the engineering group.
Oh, so this is for Carollo Engineers, and they've been assisting us, or they're the ones currently doing the model development for us, and they've done a lot of work regionally with our partner jurisdictions as well. They work with Fairfax County on their wastewater system, as well as DC Water. I think they did the study that Kendra mentioned a couple of years ago related to the PI.
So are they on our BPA or?
Yes, they're one of our BOA consultants. Yes.
Yeah, I thought I remembered seeing the name, but I didn't see any of the, I don't remember the task. So this is a good task. Yeah.
Any other questions? Want to read somebody want to read them?
I'll do it.
Why don't you do?
I move the recommendation to the board to award a task order for the wastewater collection system master plan to Corolla Engineers for an estimated cost of $459,800 with an approximate 5% contingency to be controlled by the general manager for a total authorized budget of $483,000. Additional costs will require board approval.
And
Contingent or not?
put it consent.
Consent. Yeah, consent.
Okay, call for a vote. All in favor?
Aye.
Thank you very much.
Okay, the next thing are informational items. Are there any questions on any of the items that are listed?
We do have a presentation for you.
Oh, good. Okay.
But if we want to I just wanted to talk really briefly about the work plan, if we want to pull that up. It'll just take a minute and then we can move into the construction reports, which I know you guys like to hear that information. Um, so before you is the draft work plan for this year, for this committee. And we've already been through, obviously, the first set of items. It's a really ambitious plan, maybe one of the more ambitious plans we've had in the last few years. And, this plan comes together through our CIP process, which starts at the end of the summer, early fall, right? And it kind of culminates with the approval by the CIP committee and the finance committee in November, right? So, and then we work together with all the folks that are involved. There are actually 6 different departments that present. You saw a whole bunch of them here. It's not just the capital programs team that presents. We've got people from all over the organization that present. We're looking at bringing 8 studies forward, including a couple of master plans, which we just heard. We've got like 20 design task orders that vary between linear work, R&R work, new facilities, new wastewater plant at Howardsville, and some other new facilities. And then we've also got, 15 construction related items that also are, vary between linear and vertical facilities, as well as all of the various informational items and reports that we provide you on a monthly basis, like CIP spending, and then of course the construction reports. So this is our agenda. It's a draft. I'll keep stressing that because things happen that change. Things that can affect us are permitting schedules, land acquisition, that can affect our schedule quite a bit. And also things that come up internally, right? Where we may have an energy maintenance project that comes up that needs to bump something, or changes in the community may shift our priorities as well. Did you have a question, Mr. Sultan?
Yeah,
Okay.
I don't think I need the information, but I'm just curious. Do you have any measure about how accurate you were, let's say, for 2024?
I haven't put that information together, but I can.
I don't know if you need that. It's just a curiosity.
Yes.
It's
Yeah.
so vague with all the stuff you have to do all year.
Yeah. I can take a look at that for you. And maybe the next time we talk, I can share that with you. So yeah, it's a good question.
I mean, it's tough. I know it's tough to.
It is. And these items here are either new projects, right, that we're bringing to you, like the one that Jen presented, or the continuation of work that we're working on. So this isn't everything that we are doing. There are lots of other things that are happening that maybe you saw last year that are continuing, and you won't really hear about it because it's in design, and you may not see something until 2026 because of construction. So there's a lot that goes on within this organization, and we do our very best. It is. It is. So just another point, I think everybody is aware of this, and then we can move on to the construction stuff. We meet every month except for July and December. So if we kind of keep on this track, we'll probably need every meeting that we have scheduled. Thank you.
Any questions?
Nope.
If we have to work, you have to work too.
I have a question on that one right in the middle. Okay, the next one is the capital construction quarterly report.
Thank you, Mr. Sultan. Happy to be back before the committee here to present on our fourth quarter construction report. And we've consolidated this report with the 2024 change order report that we typically give around this time of year. So you will see us transition from the fourth quarter report into that entire 2024 overview of how we performed in terms of our construction change orders as well. We've got the agenda here. It's fairly typical, 2 snapshots. Milestone and Broad Run get their phase 2 expansion, get their deep dives. And then we wrap up this portion of the presentation with the quarterly figures for the fourth quarter. And these first two snapshots, the projects are a little bit on the small side, but this is the first time that we've reported to the committee on these two since they were approved for construction. So we thought it'd be a good way to sort of give those larger projects that we typically include here a little bit of a break. Give you guys an overview and a status report on these two, and then we'll be seeing those other larger projects come back for the next quarter report. So this first one consists of some improvements at the laboratory at Broad Run. It's a project that Capital Programs is handling. The original contract value is $1.1 million, and we are just about over halfway through with construction on this project right now. Completed work, the new condensing units have been installed outside of the facility to support the improvements to the lab, and the electrical conduits and refrigerant piping have also been installed as of right now. Mr. Sultan?
For my education, what does the condensing unit do? I know it condenses, but what is it?
It condenses the refrigerant. So that's the sort of the engine that controls temperature conditions inside of the lab.
That's
So
what the
ba-
condensing unit does?
Correct. So along the way, I think the notable sort of bit of reporting here, while we started construction and started interfacing with some of the existing devices that were perhaps relied upon to bring the new work online, we did encounter some issues with some of the components inside of the lab that we did not necessarily intend to modify, troubleshoot, etc. So we are working to restore those components, those devices, terminal units, things of that sort, to their, let's say, design basis conditions so that we can carry on with the remainder of the work the way it was intended. We do not anticipate that will result in any upsets to the contingency at this time. We've been very efficient in how we've been working through those challenges, but it's something to sort of highlight here as part of this project. Now on to another slightly larger project. This one is over at the Dulles South Water Booster pump station. The purpose of this project is to address some ongoing operational issues there and increase the capacity to meet future demands. WGK Construction is constructing this one. We've now demolished the existing jockey pumps that are going to get replaced by a new larger pump. And we are just about to get to the point where we can shut down the facility before the high demand period in the year to install some of the new mechanical fittings that will allow us to connect the remaining improvements and get those online. So, startup and commissioning towards the middle of the year. And again, this one is a little bit on the low side in terms of our percent spent here, but that was part of the schedule all along. Some of the items that are included in this project are longer lead time, and we are sort of right on schedule if you look at the overall baseline for this project, even though it seems to reflect that, with over a year in construction here, it seems like too little, right? But we're right on track to complete by, I guess, Q3 of this year. Now on to Milestone. Won't bury the lead here. Still on schedule, still well under budget. I mean, on track to meet our budget. $145 million for the original construction contract, and we'll get into some more detailed financial figures here in the next slide. But we've now completed Tunnel A. This is the portal Tunnel A daylighting out into the quarry reservoir, right? And you can sort of see tunnels B and C here. C has been being mined concurrently. And as of the fourth quarter, we were still in progress with that one, but I can sort of give you the update today. We've since then completely excavated Tunnel C. No major issues along the way. I know that the risk profile with the geotechnical work on this one was a bit of a concern for the team, but so far we've been able to avoid all the major issues. So we are just about the point where we're sinking the shaft, obviously on the other side of the tunnel endpoint, if you will, to get to the Tunnel B excavation and start mining that one outward back into the quarry. Not much to report yet on the construction of the pump station itself, but we are starting to install the 42-inch raw water pipe that will allow us to fill and drain. So here's the Tunnel A portal at the quarry a little further along, right? And so some of the financial figures here, the change order total just about 600,000 for the project through the fourth quarter of 2024. And you see some of the adjusted figures, percent spent 27% with 23% of the time elapsed on the project, and still on track to hit that April 2028 substantial completion date. Yes, Mr. Vega.
On that 600,000, is it owner-directed changes? Is it site conditions?
By and large, unforeseen subsurface conditions, undercuts, rock where we didn't expect it, things of that sort. This is sort of an overview we give every month, perhaps a little bit superfluous this month, this quarter, because things are going very well on all counts here. So, just want to sort of stay with the regular program on that one. And then as per typical, we have some visualization of the progress in the tunnel, but for this one, we thought it would be a good opportunity to basically show the moment of breakthrough at Tunnel A when that last blast provided daylight for the tunnel there, right under the flag. It's barely visible here with the lighting, but you can see where we first encountered daylight. That's the status of the quarry as of the fourth quarter and the fourth quarter, how far we've drained down to allow for construction. We'll get into some AB tunnel improvements that are ongoing here with the installation of supports that will then give way to the installation of our AB plug to sort of keep the water contained in the reservoir there. Overview of the site, and this sort of shows how far along we are on the pump station side of the project, right? Still no structure to really talk about. There's the GCIP project making a cameo there towards the bottom, and little deep dive, no pun intended, into the shaft and how far along down we've gone with that. So I think I'll pause there before I hand it over to Rick. Any questions?
Okay, good morning.
I did have one.
Mhm.
I think you had payments above percent completion. One was 27%, the other
Let me go back to that.
23, was it?
Oh, that was the time elapsed, 23%.
Yeah, I'm just wondering why the money spent is more than the time elapsed.
Great question. Not to
Not by much, but
my original answer sounded a little patronizing, but it's really what it is. Geotechnical work is very expensive, and it's proceeding slightly ahead of schedule. So that sort of tips the balance. We expect that there will be catch up as the excavation of Tunnel B wraps up and we start moving into our sort of typical pump station construction and all of the mechanical and electrical appurtenances for that. We'll see sort of some divergence of those two figures. But because we are slightly ahead of schedule and it's mostly been that expensive geotechnical work, that's where you see that 27% sort of.
Change orders also contribute to that? The change.
No, not contributing to those figures.
Okay. I'm going to pick it up here with the Broad Run expansion, and I'll add, I don't have anything explosive to share like Sam's tunnel breakthrough video. So lower your expectations.
Thank goodness.
All right, so for the Broad Run expansion here, we are in the final stages of this project. Our revised contract value is 78.7 million with 2.8 million in changes. The contractor is at this point 100% spent on the work. They did reach substantial completion in November, and final completion is due in May. And so just my big highlight here is that substantial completion was achieved November 22nd. That was the effective date of substantial completion. Okay. And then,
Fantastic.
yes, absolutely. And then our project graphic here through the end of the fourth quarter, everything was complete. There was one area at our dewatering building where the contractor needed to come back. They had completed commissioning, but they needed to come back and do a little bit of optimization or fine tuning. And we weren't able to get that scheduled until early January. So that's the reason for the yellow there. But essentially, the project was, for all intents and purposes, complete in the fourth quarter of last year. Okay. And then our project summary here. So these are more or less the final stats on the project in terms of RFIs, submittals, coordination and shutdown requests, change orders as well. We don't anticipate any more change orders through final completion. I guess there's always the possibility, but we don't anticipate any. And then I'll just add that the contractor continues to work diligently to get to final completion of the project, working pretty hard on the punch list items and remaining work that's left to go. That's all I have for the Broad Run expansion. So I'm going to.
I had one,
Oh,
this
yes.
is a silly question.
Sure.
All my questions are perfectly. I got asked by a couple of people in my development what that property is, why we have so much vacant property. And I was just wondering if you want to put a sign up that said future site of whatever.
And
Just
that's,
because I got asked a couple of times.
yeah, and that property to the north is for the future expansion
I
of
just wondered if
Broad
you want
Run.
to put a sign up that says future expansion or future something, shut up, you know. That's right.
Yeah, yeah.
I would say
and-
in
and
about
nearly
6
2
months.
million an
Yeah,
acre for a
eventually.
data center. Yeah.
Right, yeah, eventually there will be some construction signs there as we ease into the construction projects.
Sometimes they wrap
Um,
the construction fencing with a picture of what's to be. Maybe we can consider that.
Yeah, so it'll be there shortly. Yeah.
Okay, so on to our summary of active projects that saw construction activity in the fourth quarter of 2024. About 10 projects here. Any questions on any of these particular projects?
Oh, any group that has 1.4% change orders is doing pretty good.
Okay. And then we have one that was completed in the fourth quarter. That was the Broad Run roofing project.
The original was 1.876 and you came in under budget.
We did,
Like that.
we had
Like
to
that.
have a negotiated settlement for substantial completion, and so
Okay.
we did.
Yeah.
We did have a slight reduction there in the final contract value.
Deal. Not that we watch the pennies. I'm sorry? Yeah.
All right. Well, now we've got our upcoming construction projects. So this is kind of our 6-month or 2-quarter look ahead to show what projects we anticipate starting construction here later this year.
That's a lot easier to handle than her list.
So this is a combined list, so it's projects that Rick's working on and
Yeah,
ours too.
there will be some, this list will have some more as we move into like the next quarter in April. You'll see some more on it. Yeah.
The generators will come in on time. No supply chain issue.
So the generator.
Actually.
Yeah,
Got it down.
It actually got,
Yeah. I
Again,
remember.
from 90 to 50. So perhaps
Improvement.
perhaps reflective of some conservative lead time estimates from electrical suppliers.
Or people double ordering.
Yeah,
Yes.
under promise, over delivered kind of.
yeah. So the generator is going to be delivered in May.
But then we get back to what we talked about before, that the tariffs and all this rest of this stuff will go.
Pendulum swing perhaps the other way to TBD.
We'll see.
All right, so we'll go ahead and turn the page then to the change order report. So this is kind of a summary of all of the change orders that we saw through 2024 on active projects. So on this particular slide, we've got our vertical projects that were in construction in 2024. The ones in bold did reach substantial completion in the calendar year. And kind of the key point here on this slide is that for those vertical projects, the aggregate change order percentage of base contract value is at 1.4% for this group of projects. And then we have another slide that just breaks out the linear projects. And so similarly here, all of these projects hit substantial completion in calendar year 2024. And so our aggregate change order total for this group of projects there was 1.3% of the base contract value.
Pretty good.
Thank you. And then just a overall summary of the change order categorization here. So through 2024, our largest category of changes, and it's been discussed a bit here previously in the meeting, was the owner requested or value added improvements that represented 36% of total change orders through the end of 2024. And then our aggregate percentage there for both the vertical and the linear projects was 1.4% of total contract value.
What was the largest project that had a design error and omission? If you know, I don't.
I mean, probably the Broad Run Phase 2 expansion.
So this table puts quite a lens on it, but it really is probably the aggregation of obviously a lot of smaller individual items, of course, that lead to this $1.09 million total. But I
Yeah.
think what Rick's pointing to is just the scale of the project and the fact that we were going into the existing plant with all of that work.
Right, with that project being a retrofit and touching so many different areas of the plant, back to my green graphic there were so many different work areas and such complexity with keeping the plant operating while we upgraded it that, no doubt there were some errors and omissions in that project. And
Can you expand a little bit on the design engineer, I mean, is this something that we attempt to recover from the engineer through their insurance company? Is it something that we are paying for where their responsibility?
so,
Can I
Go
start?
ahead, Al. Yeah.
This is a simplified version of a categorization that we go through. We spoke earlier of our change order documentation process. So within errors and omissions, we have two separate categories, one of which is discovered early, help me out with this, Rick, we would have done this anyway if we had discovered it during design. It was discovered early enough that it didn't become a cost increase.
Right.
And then we have the true pure error and omission that happened and caused delay or, caused a change that was unanticipated.
So this number is the former, not the latter.
This is the combination of the two. Now, on those that are the more egregious errors and omissions, we do get together with our designers and negotiate, concessions and so forth, whether it be on their CA services in support of the active construction project or other mechanisms. And we're bringing these BOA contracts up for renewal this year and into next year for the two sets. And it's something that we want to look at a little closer as to what teeth we have in that contract.
Oh, I'm glad you're doing that.
Right.
Thank you.
You're welcome.
Yeah, and I'll add that most of the changes in that row two cost are not the engineer errors and omissions that would have cost us more. They're more of the variety where, if it would have been included in the bid, the bid would have been higher. And so they're not the bad kind, shall I say.
I just want to make sure that we're being
Yes.
clear that the engineer is not then getting compensated to
Correct. I
design
was just going to make that
No.
point. So,
what they
yeah,
originally.
so
planned.
when it is of that type, they are not to be compensated for the fix work,
All right.
right?
Thank you.
Great question. Thank you.
And thank you for the financial stewardship of our consultants.
I've said it many times, when I was with Fairfax, we didn't do that good a job. I can freely admit it. And you're down at 1.4%. That's outstanding. But I've said that 100 times already, so.
And I also want staff for the transparency and discussion of the circumstances under each one of these. And change orders are not fun. They're always kind of like a pesky attachment to whatever complicated projects you're doing, but they're very, very necessary. Thank you.
Yes. Okay.
Okay.
Any other questions or comments?
Questions?
Thank
Mr.
you.
Lipinski.
Good morning. Kiara, can you bring up there's two reports. Bring up the one that's December of 2024 first. Yep, that one.
That's the spending chart.
I'm sorry.
That's your spending chart.
That is the spending through December of 2024. Spending was about $131 million. And building on the good news that we just heard in the fourth quarter, kind of 2024 wrap up of construction. The 131 million, it says in the table down there that it's 103% of the projection, but that's of the mid-year reforecast. The mid-year reforecast was 127 million. The initial board approved capital spending for 2024 was 148 million. So it came in at about 90%. And the numbers, the 131 million isn't quite final. Sally would probably be mad at me if I didn't say that. So I don't expect it'll change much, but it's never finalized until the audit, and then we close the books on 2024. So a pretty successful year, having spent 90% of the original 148 million. I think we would all consider that to be pretty successful. So I don't know if there's any questions on that, and if not, we'll just jump over to the January 2025, which there's not much to say to that one, but. All right, so not much to share here. This is just obviously early spending, a little over $3.5 million spent for the month of January. Most of that in capacity payments to DC Water and Fairfax Water. So no questions?
Yes, sir.
Thank you.
I guess that's the last item. Anybody have any general questions before we close or?
I have a statement, but if anybody else has anything. So everybody knows IEEE, I've been a member for 40 years, that this is Engineers Week and we need to celebrate all of our engineers. They make our lives better. You know, I'm an engineer out of the University of Dayton. There are a lot of engineers in this room, in this building, that have really made our lives better. So we need to thank, if you see an engineer, thank them for all they've done and all they're going to do. So, and since I'm a Dayton engineer, go Flyers. So, thank you. Thank you.
We should applaud ourselves. Okay, I guess that's it. Do we have a motion to adjourn? Second, all in favor?
All right.
Good meeting.
Good meeting. Thanks, everyone.